Organic acids are pretty easy. They actually are very similar to both aldehydes and amides, because if you look, an organic acid is a carbon with a double bonded O and an OH on one side, and then it has an R. So just like the aldehyde and just like the amide, right, it is going to have to be at the end of a chain. That's what that's telling me. So therefore, no numbers on organic acids either, which makes things very easy. So 3 in a row, propanoic acid. So what they did was they dropped the E and then they just added oic acid to it. So uncondensing this is going to look like this. Again, I didn't put a bond between the O and the H, but if you put one in between the O and the H, that's totally fine. So for this next one, it's 4 in a row. So butane would be 4. They dropped the E, added oic acid, the condensed version. Oh, it's an OH. Oh, and there's a typo on my notes. That's why I did that. So the typo on my notes, if you didn't find it, there should be an O right there. So I put an OH in. All right. For the next one, 1, 2, 3, 4, 5 carbons in a row would be pentane. We dropped the E and added oic acid. And there it is. Ethers. So ethers are interesting. If you've ever watched like a good spy movie, you've seen that ethers are the thing that the bad guy usually puts on a cloth, and then they cover up the person's face with it, and then the person breathes in the ether, and then they pass out, right? Well, in real life, it would never work like that. You'd have to take 1 or 2 deep breaths of that ether in order to pass out the whole time fighting the person. So, you know, there's a little movie magic going on there. But an ether can do that to you, and it does not take very long, but it definitely takes longer than the movies make it seem. Just because, you know, if you were to hold your breath, think about how long it would take for you to actually pass out from holding your breath. Most people can hold their breath for a minute at least. So you got to worry about that. Now, condensed formula and how they do it. So let's look. This one's actually easy. They're just long. So ethers are, ignore esters. We're doing them last. They're the best, so we save them for last. Here it is. Notice how they named it. They call it methyl. There's a group of 1 on the left. Then they call it ethyl. There's a group of 2 on the right. And the functional group, kind of overshot my highlighter here. Oh, it makes orange again. Is the double bonded O in the middle. So basically an ether is an O in the middle of a chain, and then you just name the chain on the left side, you name the chain on the right side, and then you slap the name ether on the end. And that's how you name an ether. So this one's called methyl ethyl ether because there's a group of 1. This is the methyl, and then there's a group of 2. There's the ethyl, and then it's an ether because it has an O between them. So uncondensed looks like this. Done. This next one, they give you the condensed. They want you to draw it. Looks like that. And this would be called 3 in a row, propyl ethyl. Technically, ethyl ethyl propyl ether because E comes before P alphabetically, but if you called it propyl ethyl, it'd be totally fine. This next one, it's 2 and 2. So you could call it ethyl ether, or you could get fancy and condense those two and call it diethyl ether. Either one is fine. So that should be CH3, and then a CH2, then an O, CH2, CH3. Last one, this one would be 1, 2, 3, 4. Butyl, 1, 2. Ethyl. Ether. That's my butyl. That's my ethyl. And then there's my ether. And there's the condensed version. So that's it for organic acids and ethers.